Hi, welcome back to Mechanics and Control of Robotic Manipulator. This particular short session, I just want to clarify what is standard and non-standard DH representation, because many of you have still have a doubt how to fix a frame and how actually like one another is actually like different. Theoretically speaking, they are not different. How you are actually like representing based on that, it gives actually like different view. So one will give like, for example, I minus one axis you take and you take all other parameter in ith instant in the sense. So you will take I minus one frame, or you can say the axis, and you will see like what ith axis look after. So based on that, you will see like how these two axes are actually like apart. So based on that criteria, you will take theta and d. Then you will actually like move forward from this joint to next joint. So this is standard. So where you can see if you write the arm matrix or whatever you call DH matrix, so all the parameter like theta, d, alpha, and a all would be in I as the denotion. Whereas the non-standard is actually like looking after like you will take one link, okay? So the physical link probably k minus one link. The k minus one link would have k minus one axis and k axis, or I minus one and I axis if it is I minus one link. So what this indicate? This indicate actually like you this non-standard form. You will start from I minus one frame and you will go to ith frame in a sequential manner. What sequential manner? First, you will actually like try to make the twist in the sense you will make it parallel I minus one to I. So this is what you call link twist. Then you will actually like travel to ith axis. Then ith axis, you can say frame would be associated with xi, and your xi minus one would be having some angle difference. That is what you will represent as the theta I. Then you will actually like see there is a distance between these two. That is what you call di. So in the sense, if you write a dh or arm matrix, that would be having mixed of I minus one and I. That's all. This is the basic difference. Because of the transformation happened in this way, so one transformation to another transformation will differ. Okay. So in the sense, if you look after standard DH representation, where you first rotate about z axis, then translate about z axis. Finally, you will actually like take x-axis rotation, then x-axis translation. This is the way the standard. Whereas the non-standard is completely different, where first you rotate about x, then translate along x, then rotate about z, then translate along z. So this transformation definitely giving different representation. Although I minus one and I mixed, but it is actually like different. Further, what you can see like the standard and non-standard is actually like differ. Your I minus one axis or ith axis in non-standard corresponding to the same actuator. Okay. So if I denote theta is corresponding to ith axis. But when I take a standard form, theta I corresponding to I minus one axis. Okay, this is the basic difference. I hope now you are clear. So we'll actually like move forward with a certain example. So before going to see the example, let me talk about the you can see how this actually like different. So this is what I said. First, what you see, like you can see I minus one axis. Okay, so this I minus one axis and I minus two axis, whatever the angle different. So that we are actually like trying to see in a different way. Now what you can see like a probably ith axis goes this. So now you take a common normal where it intersect. So that is the point I'm actually like seeing this point, and the point based on xi minus 1 hit on zi minus 1. This is the point. So now these 2 points are actually like distance apart. That is what you call joint distance. And this has some angle. So that is what you call theta I. Okay, so now further what you can see this I and I minus 1 angle apart along, you can say about xi. So that is what you call alpha I, and there is a distance along xi, that is what a. So you see the physical representation of dh parameter did not change. Okay, but what changed? So you are actually like seeing I minus 1 axis, and you are actually like first rotate about z, then translate about z, then rotate about x, then translate about x. This is what the standard. So based on this, you can actually like find standard DH matrix. The non-standard is slightly different, right? So you have I minus 1, okay, and you have high. Okay, so now what first you have to do, you have to actually like first rotate. This is alpha I minus 1, and you translate. This is ai minus 1. Then you can see like xi and xi minus 1 as a distance, sorry, angle. Sorry, that is what you call theta I, and this distance is actually like a dl. That's all. Okay, so now basically this is the difference, right? So now we write that way. So what will happen to the dh matrix, since we have first to rotate about z, then translate about z, then rotate about x and translate about x. So this will give the dh matrix like this. The other one is rotation about x, then translation about x, then rotation about z and translation, or you can say this way you can write, right? That way we are right. Then translation along z. So this and this, the matrix will differ, that's all, right? So now we will actually like confirm whether, so both are giving final end result, which you call end effector point, is giving the same or not. So for that we will take a conventional example. So what conventional example? There is a first motor. Okay, so this motor connected with a link. Okay, so this is the first rotation theta 1, and this is connected with another L link. Okay, so this as probably I call, so this as something like, so another motor. So this motor is actually like rotating another link. Okay, I'll just make it easiest. Okay, so now this is connected with one motor, and this is again connected with another. Okay, so now there is a translation motor. Okay, so this is having translation. So this is the t3 and this is theta 2. So I'll just make it. Okay, so in this sense, this is something like a piston cylinder, you can imagine. So now what it actually like indicate, so this is what you call base, imagine, and this is actually like your end. Okay, so this is end and this is the base. So what we can see, first we will try to see how to fix the frame as per the non-standard or standard. First we will take a standard one. Okay, so I'm trying to fix the standard one. So what you can see, so then you can see this, I can actually like write z1 axis. Okay, then I can write this is actually like a z2 axis, and this is z3 axis. Okay, so obviously because it is vertically down is the positive direction, right? So that's all is given. So this is actually like theta 1, and this is theta 2, and this is t3. So these informations are given, right? These information are given with us. So now what we need, we have to actually like fix z1, z2, or you can say you have to fix 1, 2, 3, all those things, right? So now what we can see, so I'm assuming that this is the base and this is the end. Okay, so this is the end and this is the base. Okay, so now what we can actually like see, we can actually like fix x-axis. So since these two are parallel, so I can actually like write, so x, so this I can actually like write it as c0, right? Because we are talking about the standard, right? So then you can actually like see, so now this way we can actually like write it. So you can actually like see this is x0. So x1 would be actually like can come because it is parallel. So I can actually like make x1. So where these two intersect, so this is the point we can actually like see the distance. So now x2 I can write. So where this intersect, so this is the distance. Okay, so now what you can actually like see, so there are several other things comes, right? So now in the sense what physically we are seeing, so the z0 here and z1 here and z2 here. Okay, so like that you can write. This is one way. So the other way around you can actually like write, so x2 and z2, and this I can write as a z3, which is the end x3. Okay, so like that also I can write. So I better write this way so that the tool you can actually like see if you take a standard form, so n plus 1 as the frame, right? So in that sense, you can actually like see there are three axes. So I put the fourth one in the sense. So this is so 2 and this is actually like 1 and this is 0 and this is 3. Okay, so now what you can actually like see, I'll redraw this for your benefit in another picture. So what we have, so we have 0th frame, which is z0, which has theta 1 as the, and this is x0. Okay, so here you have z1 and x1, and this is actually like, sorry, the direction I did not consider, right? The direction is z2. So in the previous also I'll correct it. Yeah, it is given right. z2 and x2. Then you have final frame, which is c3 and x3. You can even change, but right now we keep it this way. Okay. So now what else will come? So this is we return as theta1 as the variable, and this is theta2 as the variable, and this is d3 as the variable, right? What else is there? So there are some distance between 0 to 1, 2, and 3, right? So I'll write it. So now what I can see, so there is one distance d1, then one distance a1 and a2 and d3 are there, right? So now what would be the dh parameter here? So I can write this is a standard one. Please correct it. This is standard dh parameters, which we have drawn the frame arrangement also standard. Okay, so how many we need? 3, right? So this is I call. So this is start with theta I, then di, then alpha I, then sorry, ai. Okay, so now these are the things. So 1, 2, 3. So now we will write. So what would be this? So x0 and x1 are actually like having some angle different, because if I actually like rotate about z0, so it will actually like rotate theta1, so the x1 will vary. So that is what theta1. And you can see frame 1 and 0 are distance apart along z0, so that is what d1. Okay, so now what you can see, z0 and z1 are parallel and same direction, so there is no alpha, so that is 0. But what one can see along x0, so there is a distance between 0 to 1, so that is what I call a1, right? So now what we can actually like see, so the second case you are trying to move, so again you can see like theta 2. Okay, so then there is no distance along z1, but what you can see about x1, so there is a pi 180-degree rotation, which makes z1 and z2 are parallel right now, although it's parallel opposite direction, so the pi angle, and there is a distance which is along x1, that is a2, right? So coming back here, so z2 and z3 are actually like parallel, and as well as there is no passive joint, so in the sense now it is 0 degree, and d3 is the variable, and what you can see, both are actually like parallel in same direction, and there is no distance along this, right? So these are the three things. So you got it. So now if you want to actually like highlight what are the variables, so these three are the variable and the remaining all constant. Yes, right? So that is what you also get it. So now can I actually like check what is the standard DH matrix? So this is what the standard DH matrix, right? So you can see alpha comes somewhere here, and then you can actually get it. So now if I substitute this, so what T01 goes, so it is actually like if I substitute, so it is C1 minus S1, this is 0, and this is A1 C1, and this is S1 C1 0, A1 S1, and this is 0, 0 1, this is D1, Okay, and this is 0, 0, 1. So you can actually like cross check. Yeah, this is the DH matrix. You see alpha is 0, theta I is theta 1, and AI is A1, and DI is D1. So you substitute, this become C1. C1 means cos theta 1. This is alpha is actually like 0. So this become 1. This also become 1. This is minus sin theta 1. This is cos theta 1, and this is sin theta. These two are 0 because alpha is 0. Here alpha is actually like 0. So it become 1. This is 0, right? And this is D. So like that we have substituted, and similarly T1 to 2. Okay. So again I substitute the same way. Here at D2 is 0, the remaining all same. So in the sense C2 minus S2 0, A2 C2, alpha is actually like 90, right? So that you need to actually like check. So alpha is actually like, sorry, not 90, it is actually like 180 degree, right? So 180 means what happened? This become minus, and this also become minus 1. So that you need to actually like correct. This is also minus 1. So minus of minus, this is plus. So this is minus C2 and S2 and this 0, 0 minus 1, and this is A2 S2, and this is 0 and 0 0 0 1. And you take T2 to 3. In this case, it is actually like all 0, only D3 is there. So it is identity matrix till this. Okay. So now these are the three matrices, right? So we can actually like check further. What we can actually like, we can multiply this. So I'll write T01 is actually like C1 minus S1, 0 A1 C1 S1 C1 0 A1 S1. So I'm writing this. Okay. So 0 0 1 D1. So I'm just missing all the time here. So this is D1 and this is 0 0 1. Okay. So now the similar way I'm writing here. So this is C2 minus of minus, this is S2, and this is 0 A2 C2, and this is S2 minus C2 0, and this become A2 S2, and this is 0 0 minus 1. So this is 0 0 0 1, and this become 1 0 0 0 0 1 0 0 0 1 T3 0 0 1. Okay, so this is what the case. So in the sense T3 can be multiplied 0 1 1 2 2 3. That is what we did here. Okay, now I want to actually like multiply. So what I can do, I can keep this. I can actually like multiply these two. First row, first column. So this will give C2. So first row, second column, it will give S2. First row, third column become actually like you can see 0. First row, fourth column actually like you can see, so A2, C2 remain, right? Similar way you can actually like go first row, sorry, second row, first column. So S2, then minus C2, and second row, third column becomes 0. Second row, fourth column become A2, S2. Third row, first column becomes 0. Third row, second column becomes 0. Third row, third column become minus 1. Third row, fourth column minus T3, right? And you can see this become like this. So I'm writing this C1 minus S1 A0 A1 C1 S1 C1 0 A1 S1 and 0 0 1 D1 and 0 0 0 1. Okay, so now I'm actually like multiplying this bit. So what one can see, so you can see first rows, first column, so C1 C2 minus S1 S2. First row, second column, only like C1 S2 minus of minus plus S1 C2, right? That is what going to come, right? So this, right? So then you can actually like see first row, third column, first row, third column, what become? It becomes 0. First row, fourth column. So you can see like, so A2 C1 C2 minus A2 S1 S2, then you have plus A1 C1, right? The same way you can actually like do first row, second column, sorry, second row, first column. So S1 C2 plus C1 S2, then the second row and second column. So S1 S2 minus C1 C2, and third is become 0 here. Again A2 S1 S2 minus or plus, so this is actually S1 C2, then this one A2 C1 S2, then you have plus A1 S1, and the fourth element of, sorry, first, third row, first column, that becomes 0, then this is also become 0, and this is become minus 1, and this become D1. Okay, so actually minus D3 D1 I have to write, but I'm rewriting in this way, and this is what. Okay, so what you can actually like see, so you will get the rotation matrix which gives, so what is this? So C12, you take a minus common, so then you can see like a C12 plus S12. Okay, this is actually like going to be what you can see. This is S12 minus C12, 0 0 minus 1 0 0. So this is what, so where C12 is actually like cos theta 1 plus theta 2, C1 is cos theta 1, S12 sine theta 1 plus theta 2. Okay, so this is the rotation matrix. So now what would be the position vectors? So again, you can see like a px would be, so a1 c1 plus a2, you take it common out, then this become, so py would be, so a1 s1 plus a2 s1 2, and pz would be, so d1 minus d3, and I'm rewriting this rotation matrix 3 with respect to 0 is C12 S12 0 S12 minus C12 0 0 0 minus 1. Okay, so you cross check. So what are the things are there? So you can see, so this is Z0 and this is X0. Okay, so I'm just seeing the final tip point. Okay, so this is X3 and this is Z3. So this is A1 plus A2, and this is D1, and this is what you call T3, and this is theta 1 is 0 and theta 2 is 0. That is the case. Okay. Okay, so if I see what would be the home position? Home position in the sense theta 1 is 0 degree and theta 2 is 0 degree. What would be Px? So Px would be, so A1 plus A2, right? Py would be 0. So Pz would be, so D1 is the positive direction and D3 is negative direction, right? And coming back to X3 orientation, so X3 orientation is actually like 1 0 0, and Y3 orientation is actually like opposite direction. So in the sense 0 minus 1 0, and Z3 direction again it is 0 0 minus 1. So now you substitute the same theta 1 and theta 2 here in the solution. You can see this become 1, this also become 1, sorry, this becomes 0, this also becomes 0. So you can see A1 plus A2, this becomes 0, and this is remain, and this become 1, this become 1, so this becomes 0, this becomes 0. So 1 0 0 0 minus 1 0 0 0 minus 1, right? You are actually getting both, you can say home position and home orientations are actually like matching, right? So now you just imagine if theta 1 is positive direction. Okay. So what would be the y direction? So y direction is supposed to be positive. So we can actually like check if theta 1 is positive. So what you can see here, it is actually like giving positive value, right? So in that sense, it is actually like a true. And if T3 is actually like going up in the sense that negative direction, you can see that would be D1 plus D3. Yes, that is also matching. So then the solution is actually like valid and it is good. So but what we did as per the standard form. Now I will actually like take the non-standard form. Okay. So what we know, so we know like there is a one motor here. Okay. So there is another motor here. Okay. So this attached with another motor here. Okay. So I'll make it, this is the motor. So this is actually like a translation joint. Okay. So in the sense you can see this is the way. So this is your first joint theta 1 and this is second joint theta 2 and this is the third joint theta 3. So I am trying to fix the standard form already I have done. So now I'm trying to fix the non-standard, what I can see. So I'm trying to see where I can fix Z1. So obviously you can see this is the base, but these two are actually like parallel. If I keep this point, the common normal I can draw easily. So I put Z1 here and 1 also here. Okay. So this is Z2 and this is 2. And I'm taking this my Z3 and Z4 is common. I don't want to see that. So in the sense, this is D3 and this is A2 and this is A1 and this is D1 and this is Z0. And as per the TH, you can say ideology. So X supposed to be fixed parallel based on this. So common normal or normal direction between this. So in this case, all are actually like parallel, only direction is changed. So I hope this is, by heart. That's why I'm actually like skipping. Okay. So now what would be the DH parameter here? The DH parameter set is slightly different. So how slightly different? Because this is non-standard. Okay. So this is non-standard DH parameters. So then so 1, 2, 3. Again, I'm taking up to third frame. So here alpha I minus 1, AI minus 1, then theta I and di. I change the based on how we go. So what would be alpha I minus 1? So you look at Z1 and Z0. Is there any orientation or any angle represented along or about x0? No, because these two are parallel. And is there any distance along? No. Okay. So what is the angle? Yes, there is one theta 1, which is about Z1. So that is there. And along Z1 from 0 frame to 1. So there is a distance, that is D1. Now coming back to second frame, you can see like Z2 and Z1 are parallel and X2 and X1 also parallel, but there is one active joint. Okay. Now coming to A, you can see along X1 there is a distance. So that is what A1. And you can see like there is active and there is no distance. Now coming back here, you can see alpha, what happened about X2. So it is actually like rotated 180 degree and there is a distance along. And what you can see, there is no active joint or there is no angle between X2 and X3, the 0 degree. But what happened about or along Z3, there is a distance D3. Okay. So now we look at what are the variables. So these are the variables, right? So we got this. So now what we can do, we can actually like substitute individual transformation matrix as per this. So we can actually like substitute. You can see cos alpha minus 1 coming in the second row. And you can see like D, all those things. So now alpha is actually like first case, it is all zeros, like alpha 0 and theta is theta 1 and di is there and a is 0, right? So now based on this, I'm actually like getting the first value. So in the sense T01 become C1 minus S1 0 0 S1 C1 0 0 because alpha is 0. So then this is 0 0, alpha is 0, so this become 1 and this become D1 and 0 0 1. Okay. So T1 to 2, you can see alpha is 90 degree, sorry, 180 degree. So then what becomes? So C1 as it is, sorry, C2, so S2. So this is actually like as it is, but A1 is there. And here you can see like there is a change. Okay. So what change? So you can see alpha is actually like 180 degree. So this become -1. This is also -1. This is 0 and this is 0 and this is actually like 0 and this is 0 -1. Okay. So you can actually like check what we will get. So this is minus S2, this is minus C2, 0, and this is actually like 0 and 0 0 -1 and 0 and 0 0 1. What T2 to 3? So this is again, you can actually like substitute. This is all 0. I think I made a mistake. I'm really sorry because I was actually like continue with the previous flow. So here alpha 2 is actually like 180, but alpha 1 we need to look at it here. So in the sense what you will get. So here you will still continue as per this. It is actually like a 0, right? So in the sense C2 minus S2 0 0. This is A1 and S2 C2 0 0 0 0 plus 1. Okay, here only it will get changed. So T2 to 3, here 180 degree. So in the sense this is anyhow 1 0 0 and you have A2. Okay, so when we come here, it is actually like this becomes 0 and this become cos theta 0, but cos alpha is 180, so it has become -1 and this becomes 0, and here actually like it is 0 and here actually like a 0 0 -1 and it is actually like a minus of d3 because -1 of d3 because cos alpha -1 di, so which means actually like minus d3 and this is 0 0 1. You can actually like take this, so this column, so pi a20 d3 that you substitute here. Okay, so this is actually like 1, this is 0, this is actually like 0, this a2 remain and this becomes 0, this becomes 0, this become 1 -1, this become -1, this is 0 and this is also 0, this is 0 and this is actually like -1 and this -1 d3, so minus d3. So that is what we substituted here. Okay, so now what I'm trying to find out, so I'm trying to find out, so 1 to 3 in the sense I'm trying to find out 1 to 2 and 2 to 3. So in the sense I multiply first row and first column, so you can see C2 remains and the first row second column minus of minus, so yes, 2 remain, right? So first row third column you can see 0, first row fourth column you can see A to C2 minus or plus you can see A1, right? So like that you can see second row first column it becomes S2, second row second column minus C2, second row third column 0, second row fourth column it is actually like A2 S2 and you will get plus A1 and you come back third row first column becomes 0, third row second column also 0, third row third column -1. Okay, third row fourth column what you will get, so you can see minus here 0 minus d3 and remaining is actually like same, right? So now I want to actually like find 0 to 3, then this multiply this, so what I will get, So I'm just multiplying first row, first column, which gives C1, C2 minus S1, S2. Okay. So first row, second column, you can see C1, S2 minus of minus plus. So S1, C2. And the first row, third column, fortunately 0. Third row, fourth column, you can see. So A2, C1, C2 plus A1, C1, okay, plus or minus A2, S1, S2, okay, A1, S1, S2. I think we checked here. This column, so second row, this will not have A1, right? So I am really sorry. So there will not be anything. Okay. So now in that case, so you take this row and this column. So what happened? So A2, C2 plus A1 whole multiply with C1. That is what we did. And this would be A2, S2, S1, right? So then you can see the same way you go ahead with second row, first column. So that would give, so S1, C2 plus C1, S2. And this become actually like S1, S2 minus C1, C2 and become 0. So here you can see A2, C2, S1, okay, plus A1, S1. So then you can see plus, so A2, C1, S2, right? So then you can actually see the final row. Sorry. So you can actually like see the final. So third row, you can see like this 0, 0, 1, D1 and here. So this becomes 0, 0 and it is actually like minus 1 and it comes here. You see minus D3 and plus D1 and this is 0, 0, 0, 1. So now you can actually like check. So what is the final answer? So I will actually like write it in the next page. So T03. So what you got? C1, C2 minus S1, S2. This become actually like S1, C1, C2 plus C1, S2. Okay. So then what you will get here 0 and here you will get A1 C1 plus A2 C1 C2 minus A2 S1 S2. This is what you got it. And here what you got, so S1 C2 plus C2 S1, whatever the way you can write here. So S1 S2 minus C1 C2 and this becomes 0 and here A1 S1 plus A2 S1 C2 plus A2 C1 S2 and this become actually like a 0 0 minus 1 and this is actually like D1 minus D3 and 0 0 0 1. So this is what you got it from this particular picture. You can see, right? So now this is what you got it. So now how you can rewrite this? So this become actually like C12. This become S12. This is minus C12 and this is S12. This is minus 1. This will become like A2C12 and this is A1S1 plus A2S12 and this like this. So in the sense, so PX would be A1C1 plus A2C12. So PY is actually like you can see A1 S1 plus A2 S12. PZ is actually like a D1 minus D3. You get the same result, right? So now similarly rotation matrix. So this you can see C12 plus S12. So S12 minus C12, 0, 0, minus 1, 0. You get the same thing, but you cross check whether the same we are getting it, right? So you can see like when substitute theta 1 and theta 2 0, so Px is actually like A1 plus A2. The Py is actually like 0 and Pz is actually like D1 minus D3. And you can see X1 projected on X 0, so which means 1 0 0. And Y3 is projected on, you can say, opposite direction of Y0. So in the sense 0 minus 1 0. And the last one Z3 projected on Z0 but negative direction. So it is 0 0 minus 1. So this is exactly matching, right? So you can see like where we have tried both the standard and non-standard, and you can see like the results are actually like same, right? The same philosophy we can extend even for any other example. The result will not get changed. How you represent and what basis, that actually like if slightly changed, so then the result may change. But if you start the base frame and the end frame or the same notation or same direction, then the final end result would be the same. Okay. So that is what we are actually like looking at here. So I hope now it is very clear what is the standard and non-standard. I think the standard, some people feel it is simple, but the notation is actually like different. You take I minus 1 frame to corresponding all the joint and link parameter you write in ith instant. That is the only difference. So which makes a slightly different. You take Z0, but you write theta 1, D1, alpha 1, and you call A1. But non-standard, you take I, so then you corresponding theta and D would be in I, but you will look at I minus 1 from the previous bit. I hope you are clear, right? So with that, I'm closing this short session. And I hope you are actually like get it clarify what is non-standard and standard. If you have any other questions, you please let me know. With that, I'm closing this particular short session. Thank you. Bye.